Okay, people, we are rocking and rolling with triangles. We've got sines, we've got cosines. We are doing it all. So far we have done a plethora of amazing stuff. And so unit circle, what I'm hoping that you know the exact values. If I said, hey, sine of 60 degrees. So I'm do this backwards. The way I think about it is 60 degrees. I go like this. Sine is the y value. I know that's the longer of the two, so that's square root of 3 over 2. So that's kind of how I go. I wish I just had some um, faster way, but that works for me all the time. Hey, sectors is kind of a weird section that they put in there. Think about a pizza, think about a piece of pie. That is a sector. We have two formulas that we get out of that. Please use your reference. Know that those formulas are using radians, the shortened little versions, so be careful. Area of any triangle given side angle side. That is our good friend area equals 1/2 AB sine C. Doesn't matter about the A, B, and the C. Okay, what matters is the relationship between those three variables. A and B are two sides. Angle C is the angle between them. So leave the worry about little a, what's little a, little b. Think about the relationships. All right. Hey, we did law of cosines, and that sure worked out well. When we side angle side, we'd solve for that opposite side. When we're given three sides, we could use law of cosines and solve for an angle, and making very clear that whatever angle we have, that opposite side is given that little special treatment on where to place it on that. Hey, once again, these are formulas not to be memorized. I mean, they get memorized out of use, but sure, nice clean notes are very nice. All right, so we are moving on to the sine rule, and I'm going to pause this for a second. All right, I will go ahead and challenge you what I paused it for. What noticed in this picture? This is section 9C, the sine rule, and there's the formula right there. I'll just give it to you. If I can pick the right, there it is. Boring. You don't want a formula just given to you. You want to know where it comes from. Uh, no, it's kind of cool though. See how it can be written like this or this. I will tell you whatever you're looking for. If it's a side length, use this. If it's a side or if it's an angle, use this. Put the unknown on the numerator on the top, so then you're not kind of hustling to try to figure out what it is. So you have a choice how to start it. Which the angles go on top or the side lengths go on top. So that's something to notice there. Remember, we're talking about opposites. Hey, if you have little a over sine of a, you're talking about this pair. Okay. Law of sines is all about opposite pairs. All right. If you know one opposite pair, then and you know one side, you can solve for that missing link. Now, we're not going to use the two equal signs. We're just saying any opposite pair equaled any opposite pair. All right. So that's why they put the all three. I'll discuss that a little bit more in a second. All right, so quick reminder, the area of a triangle is the most basic form, always works, is 1/2 AB sine C. In other words, two sides, A and B, and that. Well, Mr. Sayers, wouldn't that be the same as that? If I knew B and C and the included angle is capital A, well, yes, it would. Very good. Well, Mr. Sayers, well, why are we, what about A and C and that included angle? They all work. So that's why it's kind of ridiculous to say one formula over the other. You know, two sides, included angle. But it does kind of set us up something pretty cool. We know this equals this equals this. So let's divide everything. Why not? Kicks and giggles here. I'm going to divide all three of these. So it's an equation. We're used to having one equal sign. We could have 3 or 24, whatever. I'm going to divide all these by, oh, I don't know. I'm going to divide everything by 1/2. I'm going to divide everything by A, B, and C. All three of these. What the heck? All three? What happens? What happens? I'm kind of flying all over the place here. Maybe I'll go down there. All right, so the 1/2s obviously cancel. Those are gonna go. Those are gonna go away. Now the A, B, and C are going to be selective here. So this A gets that A, that B, that B. This A stays. This B and this B, this C, this C. That A, the C. Okay, so let's clean it all up. We get sine of C is the only thing left on top over little c. Sine of capital A over little a. And sine, wait a minute. We've just derived the law of sines by using the area formulas, which we derived earlier. So everything's building. And you can either be, yeah. So it's pretty cool that we have this relationship. So let's put it in action. All right, so there's a good looking triangle. We know some stuff. We don't know some other stuff. All right, I will tell you right away, always fill in some obvious stuff. If you know 2 angles, immediately fill in the third. Why wouldn't you? So that's 150, so we know this is 30 degrees. It may or may not be necessary in the problem, but it's kind of important just to get in the habit of doing that. All right, so what do we got here? So law of cosines is this really cool trick that I know that, but we 2 sides and the included angle. We know these 2 sides sort of and that included angle, but we don't know the opposite side. So we kind of have, oh, darn it. Now, so this is where I want you to think about law of sines. What you're triggered here is if you know opposite, um, like an opposite pair. When I say opposite pair, I'm talking about an angle as opposite a side. That's that opposite pair. So I notice that I know this 13 and I know this angle 40. There's my opposite pair. Once I have that, life is pretty good. So I'm looking for a side length here. So I'm going to write this as 13 over the sine of 40. So there's my opposite pair that I know, and that should be equal to x over the sine of its opposite angle, 110. These are all numbers. We can just plug these in. In fact, would you go ahead right now and solve this for x? Oh, the magic of video. Look at that. So I multiplied both sides by the sine of 110. I plugged that in my calculator, got a totally weird answer, negative. I then realized I was in radian, so then I changed it to degree mode, and guess who got the right answer? 19, baby. So not too tough. This is a problem off your homework, sort of. Find all unknown sides and angles, if that's what's given. So let's look at it. Oh, I know 2 angles, so let's go ahead and find the third. That's 132, so that's going to be 48 degrees. We may or may not need it, but that's one of those things that you need to do right off the bat. So, all right, law of cosines. Law of cosines, do I have 2 sides? Not really. Okay, law of cosine is not going to work. So let's do, law of sines. I'm looking for opposite pairs, and I notice that I have this opposite pair. That's awesome. Which side should I go for first? Maybe AB. What do you think? AB. So we'll try to find that. And that's side length little c if you want. So I'm going to go c over the sine of 58 is equal to 7 over the sine of 48. All right, so we'll go ahead and solve that. Okay, I multiply both sides by sine of 58. Nice. Can't even tell what that is. And then we plug that in, we get 7.99. I'm going to go ahead and say that's really darn close to 8. So we know this side is 8. We know two sides and the included angle. That's a great way to figure this out. Little side A, or we could use law of sines. And let's go ahead and use law of sines because we have this opposite pair. It's going to work out every time. The 7 over the sine of 48 is going to equal A over the sine of 74. Solve that for A by multiplying both sides by the sine of 74. So we get 7 times the sine of 74 over the sine of 48. These are just numbers. Don't be scared of numbers. We're going to plug that in our calculator. We're going to get it correct. We're going to take it to the bank. All right, ladies and gentlemen, that's the sine rule. It works every time except when you have, and I've planted the seed so far, this angle side given. When the angle side is given, you need to be like, all right. Usually you're going to be fine. You're going to get one of the answers. Maybe there's two. Nobody really worries about it too much. But you know what? I want you to be the best you can be. So here's a great situation. You're given a 20-degree angle, 10, and a 5.4. If I write down the information kind of in the order that it's given, the 20 is next to the 10, which is next to the 5.4. The 20 is not in between the 10 and the 5.4, so that's important. And I write this capital A, and then I have a capital S and a lowercase s. The lowercase s goes to the shorter side. When you have this situation, there is a possibility of two triangles. A very small possibility, but it's possible. I'm not saying it has to happen because there's a lot to do with the angle measure. So what we might do here is we might find the angle, and I'm going to show you what happens when you try to find this angle using our good friend law of sine. So that's what we're looking for. So do we have an opposite pair? You bet we do. So that opposite pair is 20 and 5.4. So we're gonna, since we're looking for the angle, we're gonna put sine of, let's just call it x, over 10 equals the sine of 20 over 5.4. You guys okay with that opposite pair over this opposite pair? We're calling this x. Nice. So here's a little bit of math. We'll multiply this by 10. Plug that in my calculator. 10 sine 20 divided by 5.4. That's equal to 0.6333. When we take the inverse sine of both sides, I'll just write it. We get x equals, and we could estimate, I think it's about 160 degrees. No, it couldn't be 160 because then I'd say 140 maybe. I don't know. Let's see. Inverse sine of answer 39.3 degrees. What? Doesn't look like a 39.3 degree angle. Huh. But we trust the math. Okay, this is why it actually found a possible measurement for that. As you can see, there's another triangle I have drawn below. Why do I have this? Check this out. I'm pretty proud of myself here. Watch this as I slide this away. It kind of is trying to explain what is happening. This 5.4 could be, oh boy, this is jumpy because it's so exciting. It's just amazing stuff. So this is also 5.4. And so do you see how when we're given the 20, the 10, and the 5.4, we really have two possible ways that 5.4 could land on this other side. We don't know, where it hits. It can hit here, and then if we swing it, it can hit that line right here and form this other triangle. Um, so when I do this, it kind of gets it away, and so you can kind of see the two separate triangles. But then here it just shows you where those are coming from. So the 39.3-degree angle is correct, but it is this angle right here. And I know it boggles everybody's mind. It's hard at first, and the thing is, I just want you to kind of trust the math that we get something, it doesn't look like what you're looking for, and you're like, whether you can draw this on your own, it doesn't matter. You got to trust the math. Here's what's cool about this. Well, what is that measure? Well, if this is 39.3, this is an isosceles triangle, so this has to be a 39.3, right? So how would you find this length right here? That's 39.3. How would you find this? Oh, 180 minus 39.3. Isn't that kind of bringing up some ideas about sine? Once we have the first angle, how do we get the second angle that satisfies the same condition? You subtract it from 180. Oh, what? 140.7 degrees. So that's what that angle. So angle A has two possibilities. It is 39 or 140.7. Your calculator will always give you the smaller one first. Okay, so if I had asked you to solve this triangle and solve for this angle, you would have done the exact same thing and you would have gotten 39.3 and you would have walked away and said, I'm done. That's it. There's nothing else. So how do you recognize that there is this possibility? I don't know. There's two things I would think about. If you lay out the given and you get this, then I would take your first angle and then I would subtract it from 180 and get my second angle. Whew, that's a lot. That's like sine law is so easy, and then we sprinkle this one case and it's like, whoa. Um, There you go. Let's do one. So here's a perfect example. We have an angle side-side situation. We have the 25, we have the 11, and we have the 7. We have the angle, the capital side. Oh, so hey, be careful, be careful. All right. Uh, we want to find the measure C right there. Okay. So let's just trust the math. Sine of C, whoa, 6C, that is sick. Sine of C over 11 should equal the sine of 25 over 7. Sine of C is equal to 11 times the sine of 25 over 7. Of course, I'll type that into my calculator real quick. 11 times the sine of 25 divided by 7 is 0.664. So I'm going to take the inverse sine of that, and that's going to give me inverse sine of the answer, 41.6 degrees. Hey, I'll buy that. But since this is an angle side, I better say that, you know what? I think maybe 180 minus 41.6 is also a solution, and that is 138.4 degrees. Okay. But Mr. Sayers, that picture, I don't see it. It's hard to do. It's not about you getting the picture. It is about you understanding this situation, angle side, getting that angle and trusting the math. I have drawn a picture so that we can see it. Okay. What we found was 41.6. This is 41.6 because it's an isosceles triangle. Base angles are equal. We subtract from 180 and there's your 138.4. Two possibilities. That's as hard as it gets though. It's so easy to get that first angle and walk away. Don't freak about this. Same problem. There you go. So guess what 9C2 has a lot to do with? Oh, the angle side situation. So the first ones, these are just plug and chug, just show your work. I don't know, is six or seven problems enough? I hope. Just think opposite pairs. Good luck, everybody.